Hi everyone, in today's video we're going to be solving some problems using Newton's laws. I'm going to give you a really quick example with this system of forces we have here of what you should just be doing over and over with these problems. For this problem you have three forces being applied on this one object. So you have tension 1, which is going that way, you have tension 2, which is going this way, and then you have your gravity force, which is going straight down. So if your angle is like this is my angle of the force and this is my horizontal, then I know that if I have this angle that's right in between my two hands, my adjacent, which is touching the angle there, is cosine of theta, and my opposite, which will be the vertical in this case, is sine of theta. Then I can assume that my tension 1 cosine of theta is my horizontal component of tension 1, and my T2 or tension 2 cosine of theta 2 in this case is my horizontal component of tension 2, because they're going on opposite horizontal direction. One is going this way and the other one is going this way. I have to pick one of the two sides to be positive and the other one is going negative because it's going exactly in opposite directions. So I'm going to say my T1 cosine of theta is going to be my positive side that way, minus, it's going that way, T2 cosine of theta 2. So that's it for my f of x, which is my horizontal component. Since I was told that this object or this thing was at equilibrium or at rest, then that equals 0, because that will equal mass times acceleration, but since it's at rest, it's not accelerating anywhere, it is equal to 0. Now if we do the vertical components, tension 1, like I said before, is the vertical will be the opposite of the angle, because again you have the angle here, so my vertical line you can see is actually on the other side, so the theta angle is looking at the vertical line, so it's sine of theta. So my T1 sine of theta, and then for my T2, am I going positive or negative? Because it's still going up, so you have both tensions going actually up, it's going positive. So I have T1 sine of theta plus T2 sine of theta 2. And my f of g has, well, just a vertical component, but it's actually going down, so it's minus fg. All you have to think about, you just have to remember your equations and how to get your horizontal and your vertical components. Now let's get to some problems with this. So the question we have for this problem is, the distance between two telephone poles is 50 meters. When a boy throws a pair of shoes and it lands exactly midway between the two poles, the pair of shoes is actually 1 kilogram in mass. The wire sags 0.300 meters. How much tension did the pair of shoes produce in the wire? So the first thing we should do, as we just talked about, is make a free body diagram. What forces are exerted on the pair of shoes? Well, we have the wire. We can draw the wire as two tension forces, one to the right and one to the left. And then we have the weight of the shoes, which is just the gravity force going down. Before we start adding the horizontal and the vertical components of the force, I would like to first try and solve for the theta angle that the tension wire makes with the horizontal. We will need this angle to solve later for the tension. So since the pair of shoes we know landed exactly midway, the angle that the wire is making thanks to the weight of the shoes is the same angle on both sides. So theta is the same for tension 1 than for tension 2, so we can use the same theta angle. Since we know the length of the horizontal side and the length of the vertical side, we can calculate the angle theta now. We can use a little trigonometry here and solve for the inverse tangent of the opposite over adjacent of this triangle. We know the opposite is 0.3 meters as mentioned in the question, that is a vertical side, and the horizontal is just 25 meters because it is half from the entire wire. After we solve for the angle theta, we get that it is 0.68 degrees. Does this answer make sense? So the angle has a horizontal side that is 25 meters long, while the vertical is only 0.3 meters. So the angle adjacent to the horizontal must be extremely small. Now let's try to solve for the horizontal force component here. So since T2 is going the opposite way, it will be considered negative. So for the horizontal component, we can see that T1 is T1 times cosine theta, the same with T2 but in the opposite direction, so that will be minus T2 cosine of theta. Since we know the shoes are not moving, that is all equal to 0. For the vertical component, we must do something similar. We know T1 sine of theta is the vertical component of T1, and T2 is going to be positive because it is going up as well, so we do plus T2 sine of theta. And the weight is minus Fg, which is going down. Our first equation for the horizontal force, we can see that T1 equals T2. Remember, we know theta is the same theta on both sides, so T1 cosine of theta equals T2 cosine of theta. We can delete the cosines and we get T1 equals to T2. So now we can substitute T2 for T1 in the second equation to solve for my tension 1, which we know now is the same as the tension 2. We have two variables to solve for in the next equation, which is my Fg, or my weight of the shoes, and T1. However, we know that the weight is just mass times gravity, and the mass is 1 kilogram times the gravity, which is 9.8 meters per second square. We get that the weight of the shoes is just 9.8 newtons. So going back to my previous equation, we can just add the two T1s here and bring the weight to the other side of the equation because it's negative. 2 T1 sine of theta equals to 9.8 newtons. Or if we rearrange this to solve for T1, we have T1 equals to 9.8 over 2 sine of theta. We have theta already, so we can just solve for T1, which equals to 412.9 newtons. And that is also equal to T2, so we have solved our problem here. So that is as simple as it gets. Just find the horizontal and the vertical components of the net force and then solve for whatever the question is asking. We actually ran out of time for the second problem. I will be posting it tomorrow and showing you how to solve it as well. Please do not forget to subscribe to keep receiving notifications of these videos.